Hello, my name is Tom Fritchman and I'm an applications engineer here at Strainoptics, and today we'll be going over the correct way to operate the GASP instrument. The first step is to determine which side is the tin side of glass, because the GASP only operates on the tin side of glass. So we have our tin side detector that is supplied with every GASP instrument, and we want to turn that to the on position and place it against the glass that we plan to measure, and look through the opposite side of the glass. And what we're looking for is a sort of cloudy, milky haze that is produced by the UV light touching the glass. When we see that, we know that the side that the UV light is touching is in fact the side that has tin on it. Once we determine the tin side of the glass, the next step is to place a small amount of index matching fluid on the location that we want to measure, about 10 millimeters in diameter, and then we simply want to turn the GASP instrument on. In this case, there's a switch on the side of the battery pack that we want to flip to the on position, and then we also want to power on the LCD monitor by pressing the power button on the back of the monitor. Once we've done this, we should see some reticle lines on the LCD monitor showing that the camera and monitor are working. And we should also see some laser light coming out the bottom near where the prisms are. And if we see all of this, then the GASP is electronically working properly. And the next step is to place the prisms directly on top of the index matching fluid that we've placed earlier. Every GASP instrument should come to you in a way where it is prepared to measure on the cal plate immediately once you receive it. However, there are some small adjustments that will need to be made once you move to your samples of glass that you'd like to measure. The way that we go about measuring is, once we see the fringes on the monitor, we want to simply move the protractor dial so that our reticles line up parallel to the fringe lines. We want to leave a little bit of space between the fringe and the reticle so that we can make sure that we're staying parallel across the entire fringe. Once we've done that, we want to check the protractor dial and see where the measurement ended up. In this case, it was approximately 56 degrees on the protractor dial. And we want to compare that value to the value that is on the cal plate. In this case, it's 9,050 psi, and that's plus or minus 1 degree. So we consider the instrument to be measuring well and accurate if we are plus or minus 1 degree of that measurement. In this case, we are. So once we have it measuring well on the cal plate, we can move on to the customer samples, and we would have about 4 different ways of adjusting this GASP. And the reason we would want to adjust it is because different types of glass will have different characteristics, and that requires small adjustments to the instrument. So once you've placed it on your sample, you can first adjust the translation of the input head simply by rotating this thumb screw here, and the input head will become loose, and we can change the translation forward or backward. And the idea here is to get as much light intensity on the LCD monitor as possible. Once we've done that, we lock it in place, and we can make a fine adjustment the same way using the tilt assembly, which is this thumb screw here. You can rotate that clockwise or counterclockwise to effectively change the image quality. And we want to get as good of an image quality as possible, because we'll make as accurate of measurements when it's a very good image quality. The other 2 adjustments we can make are to the output head or camera head. In a similar way, we will unscrew this thumb screw here, and we can move this camera head back or forth. And the idea is to move it so that the fringes end up right in the middle of the monitor. And we can make a similar adjustment on the opposing side of the GASP instrument using the mirror lever, which is down here. And I can simply move that mirror lever up or down so that we can essentially, again, center the image right in the middle of the screen. Once you've chosen the correct locations for these 4 different elements, you should have a high quality image that is easily measurable. And that is the correct way to operate the GASP instrument. Thank you very much for watching.